-4 to 3 is unfortunate
wait.
because that's wrong. That's a lie.
-4 to 1.
-4 to 1. -4 to 1? Yeah, I heard what happened.
I didn't.
Where are we above the x-axis? Just after -4. All the way over to 3? No, because you've got a root over here. So you're going to have to say -4 to 1, and then from 1 to 3. Do not include the 1 because you're not positive there. You're equal to 0. That's going to be the problem for us. All right, C, find all values of x in the open interval -5 to 4, which G has a relative maximum. G has a relative max. You guys draw that in the air for me. It's been a while since we've had this conversation. Relative max? What does that look like? Relative max looks like this, right? Or the sharp kind. I don't see G. What's the thing that you do know? G has a relative max. We know G prime and F are the same thing, but relative max doesn't mean decreasing. You just said G looks like this. Diego, what happens?
Does it change from increasing to decreasing?
What changes from increasing to decreasing? You're right, but tell me which function.
F of x.
If this is your relative max, what Diego said is something changes from increasing to decreasing, G changes from decreasing to increasing. That's true. G, not G prime. G has the relative max. The problem is I don't have a graph of G. G prime makes the change from positive to negative, right? You have to go down one level. Jeanette's like, yes! G prime changes from positive to negative, but how can I talk about G prime? I don't see G prime.
Could you say F?
F. Changes from positive to negative, or as Sylvia would say, F changes from above the x-axis to below the x-axis. Where does that happen? Where does that happen? Above the x-axis to below the x-axis? I disagree.
3 to 4.
There is a place. It's not an interval. There is a place where you make a change from above to below at x equals 3. This is when it happens. I understand a lot of you guys are saying from 2 to 4 because you're like, well, starting at 2 I'm decreasing and I get down to 4. But this is saying where does the change happen? So this happens at x equals 0. Okay.
Wait, x equals 0?
3?
X equals 3.
Yeah, whatever. 3. 1 night in the Roger house. Fell asleep during Super Bowl. All right. I really fell asleep during Super Bowl. All right, D. Same graph. Find all values of x in the interval at which G has a point of inflection. Yes, points of inflection. It's been ages since points of inflection. We'll talk in a minute.
It's been too short.
Jackie says stupid stuff all the time. It's okay. She's like a broken clock. Twice a day, she gets to be right.
I dig it.
G prime changed on you from increasing to decreasing or decreasing to increasing. That's what it means for G to have a POI. You don't have G prime in front of you. But G prime and F are the same thing. So the question then is, when does F change from increasing to decreasing? And where does F change from decreasing to increasing? I look at that graph. Where does F change from increasing to decreasing?
X equals -4.
Okay, so we heard a lot of different things. I heard x equals 2, I heard x equals -4, I heard x equals -3. Where does F, the graph of F, the graph you see, change from increasing to decreasing? Okay, now we're gonna get at x equals -3, we have that change? So x equals -3, where
X
else?
equals 1.
X equals 1? Okay, I know what you're doing. Focus on this part, the change from increasing to decreasing, x equals -3 and x equals and x equals 2. Where's that change from decreasing to increasing?
X equals 1.
X equals 1. Done. That's where that change happens. This is just like all that stuff we were doing like back in September and October when you thought calculus was going to be hard. It's not, it's all good.
I thought right.
You thought it was going to be hard, now you know.
Exactly.
All right, and part E. This is where I was hoping we would get to. Here it is. This is the time to cry. Find the absolute minimum value of G. Absolute minimum should strike fear in your heart.
You have to find big F.
No. You an absolute minimum is different from a relative minimum. A relative minimum just says, looks like that. But an absolute minimum would look like something like that. Right? Absolute minimum just means lowest point. So the first thing we would do is you look for the candidate. The candidate is where G has a relative minimum. Well, where does G have a relative minimum? That means G prime, which we know to be F, changes from negative to positive. G has a relative min because G changed from decreasing to increasing, which means G prime just changed from negative below the x-axis to positive. Where does that happen?
-4.
Negative to positive. That just happened at x equals -4. That's your candidate. That's your candidate. The next thing that you want to check, you need to check your endpoints. And your endpoints, well, we know where those are. X equals -5 and x equals 4. Well, how do you check? How do you determine out of -4, -5, and 4, how do you determine which one is the absolute lowest? You need y values you need to plug in. And so this is where Mrs. Blakely, and there's so many brilliant things that she does, but I think one of the most brilliant things she does is she has her kids set up a table. And they say, okay, here are the things I'm testing. I'm testing -4, I'm testing -5, I'm testing +4. I want the absolute minimum of G, so I have to plug in to G. So I need G of -4, I need G of -5, and I need G of 4. G of -4, G, remember how we defined G in the beginning? This is the integral from -3 to -4 of f of t dt. You just have to find an area computation. G of -5, find the integral from -3 to -5, f of t dt. G of 4, find the integral from -3 to 4, f of t dt. Okay, real quick, if I could get these two groups to find G of -4, these two nuts. You guys did a great job, and you found those values, and yeah, oh yeah, it was brilliant. Oh, that wasn't the bell that rang. You guys just did it so darn quickly, and I can't find it. No! I'll keep talking until you're all in the room. Kind of what I do every day anyway.